Good morning, everyone. My name is Suman Lata, Assistant Professor, CSC Department, NATE, Maharaja Agrasen University. Today, I am going to start a topic that is distributed databases. Distributed databases. Here, we will going to cover introduction part. Topics discussed in this section are introduction to distributed databases, types of distributed databases, heterogeneous databases and homogeneous databases. Heterogeneous data storage, data replication, data fragmentation, data transparency, and centralized databases. Now, first, distributed databases system. We are going to start distributed database system. First of all, we will start with the introductory part. A distributed database is basically a database that is not limited to one system. It is spread over different sites, that is on multiple computers or over a network of computers. Here, the diagram is showing database 1, database 2, database 3, and there is a network. This network connecting the different databases at different sites. It means in distributed databases, basically database that is not limited to one system and it is spread over different sites. Distributed database system is located in various sites, and these various sites are known as or consist of loosely coupled sites, or also known as loosely coupled sites that don't share physical components. This may be required when a particular database needs to be accessed by various users globally. It needs to be managed such that for the users, it looks like one single database. Database systems that run on each site are independent of each other. It means different database systems are running on different sites, and all sites have independent database systems. Transaction may access data at one or more sites. Now, types of distributed databases. There are two types of distributed databases. One is homogeneous databases and heterogeneous distributed databases. First of all, I am going to start about homogeneous distributed databases. In homogeneous distributed databases, homogeneous means same. All sites have identical softwares, are aware of each other and agree to cooperate in processing user requests. Each site surrenders part of its autonomy in terms of right to change schemas or software, appear to user as a single system. However, in heterogeneous distributed database system, different sites may use different schemas and software. Different schema means some are using ER models, some are using tables or different structures. Different in schema is a major problem for query processing, because if there are different schema are there, so there is a need of different techniques to process a query. Difference in software is a major problem for transaction processing. Sites may not be aware of each other and may provide only limited facilities for cooperation in transaction processing. Distributed data storage. Assume relational data model. Replication. System maintains multiple copies of data. Replication means duplicate copies. Multiple copies of data system maintains, stored in different sites for faster retrieval and fault tolerance. Second is fragmentation. Fragmentation means partition. Relation is partitioned into several fragments stored in distinct different sites. Third is replication and fragmentation can be combined. Relation is partitioned into several fragment systems, maintains several identical replicas of each such fragments. Data replication. A relation or fragment of a relation is replicated if it is stored redundantly in two or more sites. Full replication. Full replication of a relation is the case where the relation is stored at all sites. Next is fully redundant database are those in which every site contains a copy of the entire database. So here data replication means fragment of a relation is duplicated or replicated and stored replicatedly or duplicatedly in two or more sites. Full replication means relation is where all sites store all the copy or duplicate or same copy of data. And last is fully redundant database are those in which every site contains a copy of entire database. Data replication have some advantages as well as disadvantages. So first of all, advantages of replication, availability. Failure of site containing relation R does not result in unavailability of R is replicas exist. Parallelism. Queries on R may be processed by several nodes in parallel. Reduced data transfer. Relation R is available locally at each site containing a replica of R. Disadvantages of replications. Increased cost of updates. Each replica of relation R must be updated. Increased complexity of concurrency control. Second disadvantages of replication is concurrent update to distinct replicas may lead to inconsistent data unless special concurrency control mechanisms are implemented. So here is one solution for disadvantage of replication. That is, choose one copy as primary copy and apply concurrency control operations on primary copy. Data fragmentation. Next topic. Data fragmentation means partition or division of a relation R into fragments. Like a relation R has several fragments R1, R2 up till Rn, which contain sufficient information to reconstruct relation R. Horizontal fragmentation and vertical fragmentation. There are two types of fragmentation which we can done on our relation in distributed databases. One is horizontal fragmentation. Each tuple of R is assigned to one or more fragments. And vertical fragmentation, the schema for relation R is split into several smaller schemas. All schemas must contain a common candidate key or super key to ensure lossless join property. A special attribute, the tuple ID attribute, may be added to each schema to serve as a candidate key. Here, the diagram showing the fragmentation methods. Here is original table there, where we have customer ID, first name, last name, and city. And we can do fragmentation by using two methods. One is vertical and other is horizontal. Vertical shards and horizontal shards. In vertical shards, we have two fragmentation, VS1 vertical shard 1, VS2 vertical shard 2. In vertical shard 1, we have taken customer ID, first name and last name. Whereas in second, we have taken customer ID along with city. Here, customer ID can be a primary key or super key of the table. Okay. And second is horizontal shards. Horizontal shard HS1 representing horizontal shard 1, HS2 representing horizontal shard 2. In HS1, we have again fragmented the table horizontally, means two rows in HS1 and another next two rows in HS2. One and two customer ID having first name, last name, and city as well as in the first HS1, and customer ID 3, 4 along with first name, last name, and city in another table. These are the examples or diagrammatical representation of data fragmentation methods. One is vertical fragmentation and another is horizontal fragmentation. Next is advantages of fragmentation. First of all, I'm going to discuss advantages of horizontal fragmentation. In horizontal fragmentation, it allows parallel processing on fragments of a relation. And it allows a relation to be split so that tuples are located where they are most frequently accessed. Second is vertical fragmentation. Vertical fragmentation allows tuples to be split so that each part of the tuple is stored where it is most frequently accessed. Tuple ID attributes allow efficient joining of vertical fragments, allows parallel processing on a relation. Vertical and horizontal fragmentations can be mixed. Fragments may be successively fragmented to an arbitrary depth. Next is data transparency. Data transparency means degree to which a system or user may remain unaware of the detail of how and where the data items are stored in a distributed system. Consider transparency issues in relations to fragmentation transparency. replication transparency, location transparency, naming of data items criteria. Every data item must have a system-wide unique name. Some criteria are there. It means every data item must have a system-wide unique name. Second is it should be possible to find the location of data items efficiently. It should be possible to change the location of data items transparently. Each site should be able to create new data items autonomously. Next is centralized databases. A centralized database is basically a type of database as the diagram showing. Centralized database is there and client 1, client 2, client 3, client 4 are able to access that. A centralized database is basically a type of database that is stored, located as well as maintained at a single location only. This type of database is modified and managed from that location itself. This location is thus mainly any database system or a centralized computer system. The centralized location is assessed via an internet connection, LAN, WAN, etc. This centralized database is mainly used by institutions or organizations. Centralized scheme name server. The structure name server assigns all names. Each site maintains a record of local data items. Sites ask name server to locate non-local data items. Advantages. First advantage of centralized scheme is it satisfies naming criteria 1, 2, 3, but disadvantages are there. It does not satisfy naming criteria 4. Name server is a potential performance bottleneck and name server is a single point of failure. Advantages and disadvantages. Since all data is stored at a single location only, thus it is easier to assess and coordinate data. The centralized database has very minimal data redundancy since all data is stored in a single place. And centralized databases are cheaper in comparison to all other databases available. Disadvantages. The data traffic in the case of centralized database is more. If any kind of system failure occurs in the centralized system, then the entire data will be destroyed. Comparison between distributed and centralized databases. Distributed databases, multiple database files are stored at various locations, whereas in centralized, it is made up of a single database file. In distributed database, multiple people can access and change data at the same time. However, in centralized database, bottleneck occur when numerous users or number of users increases access the same file at the same time. Files are sent swiftly from the user's closest location. Here in centralized, it's possible that delivering files to consumers will take longer. In distributed databases, data can be recovered if one of the sites fail. In centralized database, in the event of a system breakdown, a single site equals downtime. The synchronization of several files from various databases is required in distributed database, whereas in centralized database, in a single central system, it is easier to update and manage data. Thanks. In this topic, we have covered distributed databases, types of distributed databases, various methods and disadvantages, advantages of distributed databases, and centralized databases. All as well as we have covered the comparison between centralized and distributed databases. For in the next style, we are going to cover query processing topic.